All right, what we're looking at is the shell method, and it's a different way to find the volume of a solid. It's a little bit different than the disk. And if we look at what happens here, they partition this off, and what you're thinking about is adding up all the different shells that you would get. So it's kind of like using a cylinder versus using a circle like the disk method did. Okay? Um, and to get that formula, it's going to be a different formula. And as you're looking at this one, realize that, see how this rectangle is a vertical rectangle, but they're rotating around the Y. So that's the difference between the shell and the disk. If I'm going to go around the y-axis, I actually use my function in terms of x. If I'm going to go around the sorry about my picture here. So if I'm going around the y-axis, I use my function in terms of x, where, let me redraw this picture kinda. If I'm just have, I don't know, just some function here, like this, if I draw my rectangle horizontally with the shell method, that means I want to go around the x-axis. Okay, so that's the big difference between shell and disk, is which axes you're going around. With the shell method to go around the y, you use f of x. With the shell method to go around the x-axis, you have to use your function in terms of y. Now, the formula for the shell method, it's a little bit different, but basically what happens is you have a cylinder, right? There would be a cylinder if it was all closed in. So the volume of a cylinder is pi r squared h. But then you have to subtract the other cylinder because you have a hole in this, right? Because it's a shell, not that. Well, and you can look in the book. The book showed this, so I'm not going to prove this here, but what they did is they said R is like, what did they let R be? I think they said it was P plus W over 2, and the other one was P minus W over 2. And they showed that. And if you'd FOIL and stuff, you come to the formula that the volume of this is equal to 2 pi times PHW. That's what the book shows. So please make sure you read that in there. P is the radius, and H is the height of the cylinder, and W would be the width of each shell. So W is the width of the shell, and the width of each shell is delta x. So now I have 2 pi times this radius function, which they call P of h, or P of x, I'm sorry, times the height, which is h of x, times delta x. Sometimes I just say it's the radius times the height. That's just easier for me. Sometimes I just write it as 2 pi times the radius times the height times delta x. And the reason we can use 1p, and that's what they explain in the book, is that they put this as p, and then this would be p plus whatever and p minus whatever, so that we have the same relative radius. So if you want to add up all the shells that would happen there, because you'd get a whole bunch of them to infinity, your integral would go from a to b of 2 pi times the radius, which they use P of x, times the height of the cylinder, h of x, times d of x. And this is if you're going around the y-axis, because your rectangles were vertical. Now if you're going around the x-axis, I'm just going to use different variables, c to d, it'd still be 2 pi, but now your radius would be in terms of y, so it would be p of y, and your height would be in terms of y, h of y times dy. This goes around the x-axis, and with the shell method, that means that this one would be horizontal. And they show a nice picture of that in the book, so use that one from the book. All right, so let's try one. We're going to look to see if we can find the volume of, we'll do 2 real quick here. We're going to let y equal 4 minus x squared, y equals 0, and we're going to revolve it around the y-axis. I personally think that the shell method works best if you're going around the y-axis. And remember, we're just assuming that we're in the first quadrant here. So if I graph this quickly, this goes to 4, this goes to 4. So this is an upside down parabola, and I'm going to revolve it around the y. And since I'm using the shell method, my rectangle would go vertical. Okay, so my integral, and I'm in terms of x, so I'm going to say my integral goes from 0 to 4 of 2 pi. Now the radius, what is the radius? The radius is the distance from the axis that you're revolving around, so the distance from this axis all the way to the rectangle that you pick, no matter where the rectangle is. Well, the distance from this axis to any point out here is, it changes, but it's always x. So my radius for this one is just x. That distance is x times the height. The height of my rectangle, no matter where I put it, is the function, and the width is dx. So I can rewrite that. I can do some algebra. I get 4x minus x cubed dx, and then I can integrate that, and I get 2 pi goes, let's see, that becomes 2x squared minus x to the 4th over 4, from 0 to 4, and I don't know what that is, but you can figure that out. All right. Next, let's say we have two functions, y equals x squared and y equals 4x minus x squared. So graph them, see where they intersect. Here's x squared. When x is 1, that's 1. When x is 2, this is 4. It's a really nice graph I have going. That one looks like that. Let's see what I need for this one. This one, when x is 0, it's 0. When x is 1, this one would be 3. When x is 2, this one is 4. Oh, look at that. They intersect there. Like I knew that already. So now you have this little piece here. If I draw a rectangle in there, I'm just going to draw a line for my rectangle because my picture's little. I apologize. So there's the rectangle that I'm drawing. So my integral, by the way, I never told you, but let's just put this around the y-axis too. My integral is going to go between 0 and 2 of 2 pi, right? Because our vertical rectangle means we use the x value, so 0 to 2 of 2 pi times the radius. How far is it from the y-axis, because that's where we're revolving around, to here? That would be x. Again, it's not always x. Depends if on the function. We'll maybe look at one in class. Remind me to show you one in class like that. Times the height. Well, the height of this rectangle would be this top function, the red one, which would be 4x minus x squared, minus the black function, which was x squared dx. And so you get, I'm going to put 2 pi out front here, 0 to 2. That would become, what, 4x squared minus, what would that be? Negative 2x squared, so negative 2x cubed dx. So then you would integrate this. 2 pi, oops, that would become 4x cubed over 3 minus 2x to the 4th over 4 from 0 to 2. Now, I just want to show you one more thing as I was talking about there. If I went, and let's say I still did the same function, so I'm going to still use these two. And so this was my bottom function. It looked like this. And my top function went from here to here to here. So it kind of went like this. Whoops. And this one was more curved this way. Let's say this time I want to revolve around x equals 2. So here's x equals 2 right here. My integral still starts with 2 pi. I'm still going from 0 to 2 on the x-axis. The thing that changes is when I draw this my rectangle in to check for my radius is different. My radius goes from wherever I'm revolving, right here, to this rectangle. This distance right here that I'm drawing right here, that distance, my radius is 2 minus x. It's always going to be 2 minus something, so 2 minus x. The height stays the same, so 4x minus x squared dx. Now, then on this one, you can integrate this. You would distribute, FOIL, do whatever you need to do, and then integrate to get your answer. All right, so that happens quite a bit where it's not always around just the y, it might be around x equals 2, which is similar to the y-axis, it's just your radius changes. And remind me in class to look at one that goes around the x-axis so that we make sure we know how to put things in terms of y. Have a good day.